Hello, this is a video about stoichiometry using grams from the class Intro to Chemistry, and I'm Fred Oakes. In this video we'll be doing two things. First, quickly reviewing how to complete a chemical reaction. This is from previous material. Secondly, we'll be working through a stoichiometry problem using grams. Okay, there are other ways of doing this. We can use stoichiometry using molarity and the ideal gas law, and I'll address those in further videos. First, the chemical reaction. Let's take a chemical reaction where we have aluminum and oxygen reacting to form aluminum oxide. Now, if you look at this reaction, you'll see that there's some problems with it. The first problem you might identify is the fact that the ionic compound aluminum oxide is not charge balanced. Aluminum has a +3 charge, oxygen has a -2 charge, so we have to charge balance the compound by having 2 aluminums and 3 oxygens. Another thing you might notice about this is that there's a diatomic molecule here. That is to say, oxygen is always diatomic when by itself. So we'll put a 2 there, so we have O2. Now the third thing we need to do now, if you look, is we have too many aluminums on one side and not enough on the other. It's not mass balanced. So we're going to mass balance this by putting coefficients in front of everything. We'll put a 4 in front of the aluminum, 3 in front of the oxygen, and a 2 in front of the aluminum oxide. That way we have the right number of aluminums and the right number of oxygens on both the reactant and the product side. So now that we've got the chemical reaction, let's do something with it. Let's do some stoichiometry. Here's a stoichiometry problem that might be typical in the class. If we have 10 grams of aluminum and we react it with enough oxygen gas, how many grams of aluminum oxide are produced? Let's take the pieces of the numbers out of this problem and put it next to the reaction. 10 grams of aluminum and how many grams of aluminum oxide. So how do we get from grams of aluminum to grams of aluminum oxide? Well, we can't do it directly. We can't go there directly, but what we can do is go through moles. So that's what we'll do. We'll take the grams of aluminum and convert them into moles of aluminum. In other words, converting it to something else that we can translate. Those moles of aluminum will trade then to moles of aluminum oxide. And I'll show you how to do that in a little bit. And then finally, we'll take the moles of aluminum oxide and go to grams of aluminum oxide. There's our 4 pieces, or a 3-step process. Grams to moles, moles to moles, moles to grams. Let's convert that now into a problem. So we're going to take that 10 grams of aluminum and put it into something that I'm calling the Fred's famous fudge factor. It's literally just a way to convert one thing into another thing. So the first step of this process is to take that 10 grams of aluminum and put it in the upper left corner of this grid. Now we're going to get rid of the unit grams of aluminum. To get rid of that grams aluminum unit, we'll put it on the bottom. Great, now that's canceled out. What are we taking it to? Well, grams goes to moles. So grams to moles. Now that we've got moles of aluminum, we want to get rid of that unit. To get rid of that unit, just like before, we'll put moles of aluminum on the bottom. And then we'll convert it to moles of aluminum oxide. And then finally, getting rid of moles of aluminum oxide unit, we put it on the bottom and go to grams of aluminum oxide. So we now have all of our units canceled out so that the only one left is grams of aluminum oxide in the upper right-hand corner. Got it? Okay, great. Now let's put in some numbers. The first few numbers are relatively straightforward. For every 1 mole of aluminum, there's a certain number of grams of that. That's called the molar mass, and we look that up in the periodic table. For the next series, we get the coefficients from the chemical reaction. That's why we did it. So in this case, 4 moles of aluminum and 2 moles of aluminum oxide. You see where those coefficients come from? Okay, the last step then uses molar mass again. For every 1 mole of aluminum oxide, we have a certain number of grams, and we go to the periodic table, add up 2 aluminums, 3 oxygens, and get 101.96. We've now set up the calculation, and let's talk about how to do it. The top of the calculation is used to multiply. In other words, we're going to literally multiply all those numbers together. On the bottom of the calculation, we're going to divide. In other words, we're going to divide by each of those numbers in a row. So let me read it off to you. In other words, we're going to take 10 times 1 times 2 times 101.96 and divide it by 26.98 divided by 4 divided by 1. You're literally hitting the divide key or the multiply key each time I'm talking about it. And at the end of this entire process, that's when you hit the equal sign. Don't hit the equal sign in the middle. It's really not necessary. So once that happens, you'll get an answer. The answer in this case is 18.9 grams of aluminum oxide. That's how much aluminum oxide you produce if you react 10 grams of aluminum. Now remember, it's got to have the right number of significant figures, and in this case the number of significant figures are 3, since the data, the stuff we start with, is 10.0 grams. So don't forget significant figures. Okay, there's our formula, and there's our answer. 18.9 grams of aluminum oxide.